Hi, this is Brandon Baines of the Math Department at Lipscomb University, here to talk with you about the definition of a quadratic function. In this presentation, you'll learn how to recognize a quadratic function by looking at the function's equation. You'll also learn how to recognize a quadratic function by looking at the function's graph. A quadratic function is a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. A key aspect of this function's equation is that the highest exponent in the equation is 2. The graph of a quadratic function will look like one of the two graphs below. They're both U-shaped, either opening upward or opening downward. We know whether a quadratic function will open upward or downward by the leading coefficient, which we're calling a in this definition. If the leading coefficient, or a, is greater than 0, then the parabola will open upward. If the leading coefficient, or a, is less than 0, then it will open downward. If a function's graph does not look like the previous two graphs, then we will know it's not a quadratic function. Let's take a look at an example. Which of the following functions are quadratic? A, f of x equals 3x plus 2. B, g of x equals x cubed minus 2x squared plus 3x minus 12. C, h of x equals 5x squared plus x minus 4. D, j of x equals 3 times the quantity x plus 2 squared plus 1. To answer this question, we could do several things. One thing we could do is to graph each of these functions. If we graph these, then the ones that have the shape as outlined on the previous slide, I'm going to go back to the previous slide. When we graph these functions, they don't look like this, which is called a parabola, okay, or U-shaped. Then we're going to know they're not quadratic functions. If they do look like that, then we can feel pretty sure we're looking at a quadratic function. Another way that we might answer this question is to just look at the function's equation. Quadratic functions are functions of the form ax squared plus bx plus c, where a, b, and c are constants. And a key aspect to this definition is that the highest exponent is 2. Part A is not a quadratic function because it's not of the form f of x equals ax squared plus bx plus c. B is also not a quadratic function because it's not of the form f of x equals ax squared plus bx plus c. We'll scroll back to see both of those functions one more time. Part C is a quadratic function. Its equation is of the form f of x equals ax squared plus bx plus c. We can even identify the values of a, b, and c. Part D is also a quadratic function. Let's scroll back and take a look at Part D's function. So off cuff, it doesn't look like ax squared plus bx plus c, but we can see that if we have this 3 times x plus 2 quantity squared plus 1, we could simplify that by multiplying x plus 2 times x plus 2, and also multiplying that by 3, and then adding 1 to that. So when we multiply x plus 2 times x plus 2, we get x squared plus 4x plus 2. We're going to multiply that by 3 and add 1. And when we fully simplify that, we end up getting 3x squared plus 12x plus 7. So we see that a is 3, b is 12, and c is 7. Highest exponent is 2. And so this is a quadratic function. The form of the function in part D is a special form of a quadratic function, which is called vertex form. We'll discuss that form in later apps.